Hello, everyone. Come on in. I'm glad to see y'all all came here so early. That's awesome. Feel bad for not coming a little earlier myself. I've been just sitting here waiting, but I'm glad I signed in a little early. Y'all are welcome to ask me questions before we get started if you want. We currently have 8 of you here out of the 24 that's enrolled, and we got a little bit over 5 minutes left before class starts. So, as I said, you can ask me questions, or you just may sit there. Uh, you might want to start looking at the syllabus so you can get some ideas. I'm not going to talk too terribly much about the syllabus. So let's leave it pretty, it's pretty self-explanatory. But of course, if you have any questions, by all means ask them. I'll just point out a few key things. To be honest with you, the most important part is that you go to the last page of the syllabus and you cut and paste the document there into a Word document and then type in your answers. If you do that, and read enough of the actual syllabus to get that done, then you'll probably have a pretty good understanding of the syllabus already from that. But like I said, feel free to ask me questions as well. Hmm.
I did have a question real quick.
Yes.
On the Axis Pearson, will that be where pretty much every assignment's going to be other than tests, or will there be assignments on Canvas as well?
Canvas has some things that are useful, but pretty much the only thing that'll be on mastering is the what I call the homework assignments. So one's what we call chapter one homework, chapter two homework. They're actually problem sets where you have to use equations and solve them. And then the other one's conceptual questions. Some of those require a little bit of work, but it's mostly just concepts. Both of those are considered homework, but that's all that's on my lab at mastering. Oh, excuse me. The practice tests, the links to the homework, the online tests, and the face-to-face tests, and the labs are all, well, if you have me for lab, and the labs are all in the actual Canvas side. Good
Okay,
question.
thank you.
No problem.
You said besides just looking at the syllabus, it was the last page of what to print out with the syllabus?
If you read that, it'll say begin copy paste area, and then it's got several sentences with fill in the blanks, and then it says end copy paste area. That's what you're supposed to be copying into a Word document and answering.
Thank you.
No problem. Feel free to ask more questions if you have them. We still got about 3 minutes left. I do have the syllabus pulled up on my page. You'll notice my phone number's there. And if you read the syllabus, you'll notice that the one of the ways to communicate with me is via text messaging. So by all means, use that. I'm sorry this has not been going on for a couple months now, but it seems like now that I'm getting ready to teach class, I'm starting to yawn again. It's been a hallmark of my online classes in the afternoon is I tend to yawn repeatedly. I thought I had defeated that monster, but clearly I have not because it came back today.
I was looking through the online book. I noticed it was there was like a lot of videos along it as well. Would you say the videos are are better, or the actual text is better for getting the information?
When you're saying videos, you're talking about video links within the electronic textbook?
I put the code I got into Pearson,
Hmm.
and I had to like actually go searching for the electronic textbook in there. It brought up like videos first for like physics classes.
Gotcha. I have no idea how good those videos are, but by all means, make use of them since they're available for you. Uh, I actually have a YouTube channel that we'll be using, and for instance, tonight after we're finished with lecture, this will be put in a proper format, and then I'll post it to my YouTube channel as well there. So even if you miss, you'll still have access to this one. In addition to that, I literally have thousands of hours of videos on my YouTube channel, and I have a catalog more or less that tells you what are all the videos on my YouTube channel. So you can search through that to look for videos. The vast majority of the videos, though, on my YouTube site are complete lectures, which is not necessarily that wonderful. Especially, for instance, the summer lectures tend to be like 3.5 hours long. So they're really, really long YouTube videos that you wouldn't necessarily want to watch. But you can, fast forward to a problem being solved, watch the problem be solved, then fast forward to another problem, so on and so forth. But they're available for that. That being said, I would say you should try your best to learn to be able to read the textbook and get as much information out of reading the textbook as possible. But obviously, it helps to see a little bit more videos of people solving problems. There can be a point where it doesn't help you, it actually harms you. For instance, if you see too many solutions, you've sort of robbed yourself of the ability to figure out how to solve a problem. And if you've done so many of them, you might have worked enough that you probably, shot your, well, diminished all your opportunities within the kinematics realm or something like that. So just be careful. What you want to try to do is really try to solve problems without any help. And then if it gets so bad that you can't get started, then you get a little help, and then you close the help and try to work some more. And then if you run into a dead end, go back, look at the help some more, get further along in the solution that you see on a video or in a textbook or using a AI or something like that, and then once you've read further along, close it again and then try to solve it again. That'll help you be more in tune with the learning of the physics as opposed to just memorizing it. And if you don't do that too terribly often, then you won't rob yourself of a lot of opportunities. So I
Okay.
would say generally the reading of the examples is the single most important thing within the textbook. And then there on out, it's just a matter of seeing neat little tricks we use to solve problems.
All right. Thank you.
I'm sorry I couldn't offer a more succinct answer, but I'm a wordy dude. Anybody else have any questions? All right. Well, it is time to get started. So I'm going to start off and share my screen with you guys. I'm not showing the very top of the syllabus specifically because I have my phone number up there, and this is obviously going on the YouTube channel, and I don't really want everybody on the internet to know my phone number, but it's up there. What I want to express to you is if you guys want to contact me via email, then you need to do three things. One, you have to email me with only your TCC email account. Two, you have to include your first and last name within the email. And three, the beginning of the subject line of any email you send me, and that includes when you're replying to an email that I sent, you have to at least move over the original memo or completely erase it and then type in PHY, or you can even leave off the PHY and just type in 241 night. So 241 night has to be on your subject line for me to actually look at your email. So make sure you do that. That being said, I use so many different platforms that sometimes Outlook doesn't behave as properly as I'd like. So sometimes an email will be picked up on one platform, and maybe the settings for Outlook on that particular platform is such that it removes the email from the server, and then I go into another platform using Outlook again, open that up, that email's not there. If that happens, then that means this an email I didn't see. So occasionally I've discovered that I miss students' emails. For that reason, I've given you all my personal cell phone number, and I ask you to contact me whenever it's really something that's time urgent. For instance, like if you're coming in for a face-to-face test or a final exam and there's an accident or something, you need to get a message to me in a very specific, narrow range of time. That's the perfect time for you to text me. I wouldn't advise calling me because I don't answer phone calls from numbers I don't know, and I'm not putting your numbers in my contact list, so it won't do that. But if you send me a text message and I decide that we need to discuss it, then I will watch for your phone number and make sure my phone rings and all that good stuff. But the main thing is, if you don't get a response from me within 1 day from your email, one business day, and that's defined in the syllabus, so read over the syllabus, you'll see how that's defined. But if you send me an email and one business day later you haven't got a reply from me, then that's a really good time to go ahead and send me a text message. Okay. You can also completely bypass the email and just send me text messages to begin with. But again, when you do send me a text message, I need you to give me your first and last name every time you message me. And I need you to let me know that you're in 241 night each time you text message me. Otherwise, I have to sometimes scroll up a long series of messages and figure out who am I speaking with. Okay. So, anyways, those are two major rules. I will tell you some other stuff from the syllabus that's not necessarily that super normal. So you can see on the syllabus here, here's the course information, prerequisites. This is sort of boilerplate stuff that we do as part of the VCCS system. We have a quantitative literacy and scientific literacy. That's pretty generic boilerplate stuff. This is the very specific details on what you need for the course. In this case, since you're an online class, you also need to have a very good computer and internet service and a computer that can run Canvas, Canvas Quiz, Respondus Lockdown Browser, Respondus Monitor, and Zoom. That's just in case certain types of testing modalities are used. You need to be able to have access to Respondus Lockdown Browser and Respondus Monitor. Some of that's not necessarily needed if you're just using our typical proctors, which is either you show up at one of my classrooms to take a test, or you show up at one of the testing centers on any of our campuses, then you don't necessarily need those special abilities of your computer. So, anyways, scroll on down a little further. This tells you about the chapter homeworks and stuff like that. Specifically, I want you to know, as I mentioned earlier, there's homeworks that have titles like CH, then some number, and then HW. And then there's uh, homeworks that have titles like CH, some number, and then conceptual. Both of those types of homeworks is what I call online homework. So when I refer to online homework, that's what I'm referring to. And those are all, both of them are on MyLab and Mastering. Uh, you should not ever, 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 you should not try to get into MyLab and Mastering from the internet. You need to first go into Canvas and then get to MyLab and Mastering. I've done what's called a deep sync, and I've been explained or had explained to me from the people at MyLab and Mastering that if one of you students were to figure out a way to access the online course at MyLab and Mastering without going through Canvas, then you'd prevent me from having your grades transported into Canvas. That's what the hard sync or the deep sync does in my class is it automatically refreshes your homeworks when you do them and puts them straight in my grade book. So if you access it another way, that's going to prevent me from actually seeing those grades, and that would be a problem. So make sure you only access the homeworks through Canvas, and you'll be able to see the grades there in the grade book. The grade book sort of keeps a fairly decent record of your scores. I would say if you really want an accurate member or accurate figure for what your score is at any point in time, you need to download the Excel spreadsheet in one of my modules. I'll show you that a little later, and keep track of it on your own because there's no real good solid way to consistently set up a grade book in Canvas such that someone doesn't get misled. Meaning, for instance, one way you set it up, it starts counting as zero as soon as anybody starts doing a particular homework assignment. Anybody that hasn't done it gets a zero for that. Another way you set it up is it doesn't count that homework grade until it's all due, in which case all the time that it's not due, students don't see the effects of their grades. So it's just a lose-lose battle. It's much better for you to one learn how to calculate a weighted average, and two keep track of your own grade and be especially people that are physics and engineering and chemistry majors or pre-med people. If y'all can't do a weighted average calculation, you've got some real problems. So definitely do that. Now, going on further, this is where we talk about the descriptions of the assignments. You are allowed up to 1 week late to turn them in. I will tell you that, again, you need to go through Canvas to get to these assignments. And generally speaking, there's one set of problems that's labeled CH1HW, and there's one conceptual set that would be labeled CH1 conceptual. But occasionally you'll have multiple sets of homework for a given chapter. So, like chapter three, for instance, I think it's chapter three, has homework set one and homework set two. So, in that case, you got three sets of homework total for chapter three. So, be mindful of that. Get them done. And I want to express this to you. Even if you don't have your access to MyLab and Mastering yet, if you haven't bought the access code, that doesn't matter. Your homework is still due Sunday, and you got to get it done Sunday. Okay? August 31st is when your homework for chapter one is due, and there's no excuse for you missing it because you're under a free trial right now. So all you have to do is go into where it says modules right here, click on that, then go to week one module, click on homework for chapter one, and it'll give you a choice to put in your access code or to use the trial period. If you don't have the access code right now, you just use the trial period, and then later, when the trial period is over, you'll be required to go ahead and purchase it and be locked out until you're done. Okay, so just make sure you keep that in mind. You can do your homework, and there's no reason to be late, and you're not going to get an extension if you are late. Okay. Uh, I tell a little bit about cell phones and stuff like that. You should read all this. The more important stuff is the schedule. So the schedule is tentative, but the thing that doesn't change about the schedule is the order of the chapters and the chapters that are covered. So you can see clearly it's chapter one, then two, then three, then four, then five, then six, then seven, eight, 9, 10, 11, then I jump to 14, then I jump to 15, and then if we actually have the time, we go to chapter 36, which is special relativity. So that's always going to be the order, and not only that, I've allotted myself, for instance, today and Wednesday to do chapter 1. If I don't get all the examples done for chapter one, we're still finished with chapter one. Okay. I try to work the most difficult examples so that you can learn the most difficult stuff, and then I leave the rest to you to study either by reading your textbook or looking at the copious videos that I supply in my modules. So I give you a ton of videos. Most of them, of course, like I said, are complete lectures, but you can still, like I said, fast forward through them, get to a problem solving, look at the problem, watch me solve it, then scroll fast forward to the next problem, so on and so forth. But either way, this is the schedule we're going to be sticking to, and I'll do my best to cover 99% of each chapter, but not always will we be able to do all the examples in a chapter. And all the sections are assumed to be covered and required for you guys unless I explicitly tell you otherwise. So just keep that in mind. Uh, you can see withdrawal dates, online test dates, they're due. Proctored tests, those are the face-to-face tests. You actually have to have those proctored either at a testing center One of our campuses is free, or you can come in and take it at one of my classes. If you can't fit into those two paradigms, there's a long list of things you got to do, but there is other possible ways of having your test proctored. But notice this is due 10/5. I need you to start doing that 2 weeks ahead of time because basically the test will come available usually about 7 days before it's due, and I need to know where you're going to be proctoring it before that second week starts. So you want to let me know if you're having problems 2 weeks before the due date. So 2 weeks is sort of the bare minimum. So keep that in mind. You can see we're going to have an online test, which is open book, open notes, open internet searches. The only thing you're really not allowed to do is look at something that someone has created after the test was posted. So, for instance, right now, online test one has already been posted. So, anything made August 25th or later, you're not technically allowed to look at. That's just supposed to prevent a student from coming in, taking the test, and then creating a website that tells you all about the test. That's why I do that. But to be honest with you, the online tests are a very low percentage. They're really there to give you some confidence and to make you feel better acquainted with what to expect on the actual face-to-face slash proctor tests. You get multiple attempts. Usually, I give you 3 attempts and I only count your highest. You are allowed open book, open notes, open other books, open other people's notes, and you're even allowed to do Google searches. Okay. Again, the only real rule is you're not supposed to look at something that was created after the test was released. Uh, that being said, you have a limited amount of time. So if you look up very much, you're shooting yourself in the foot in terms of the learning, but you're also not helping yourself grade wise because you could run over the time. And if you run out of time, there's a lot more points that could be taken off. That being said, lately I haven't even been doing it that way. What I want you to use as a rule of thumb is when you're taking the practice tests, which I do make, okay, and the online tests, which are also sort of practice tests. But those practice tests and online tests, if you're looking up a question every test, that's not very good, meaning you're not well prepared. Each time you take the practice test, if you have to look up one, you're not far enough along yet to be prepared to take the actual online test or the face-to-face test. What you want to do is be able to, consistently get an 80 or higher and go, 2 or even 3 test versions that you take before you actually have a question you have to look up. Okay, that's really the gold standard. If you're doing it more frequently, then there's a high chance that you're actually uh, sort of defeating your own ability to learn. Okay, so you really want to be mindful of that. That being said, I would like to make the online tests last a lot shorter, but I've discovered that there's some students who just can't work fast enough to do it that way. So I've sort of relinquished the timing and allowed a lot more time in the practice test as well as the online tests than I feel comfortable with you using. But that's mainly so that you can work slowly and deliberatively without having any negative repercussions. So try to keep up with that. Try to do a little faster. Try to finish them well under time. But like I said, you shouldn't be looking up more than one question every 2 test attempts. Now, the practice test, you can take that an infinite number of times and only your highest will count. Not only that, at the end of the semester, I will take your highest score from each of the practice tests, average them, divide that average by 20, and that many points will be added to your comprehensive final exam, not lab final. That's a really big deal because the comprehensive final exam is tough, and that will help you a lot. So keep that in mind. As we go down here, you can see questions about AI. I want you to read that so you understand. Notice I'm roughly on a 10-point scale, but I give you a little help. So if you're just barely trying to get a C, instead of having to make a 69.5 or higher, I allow you to get it at 68.5. The same thing with a D. Instead of 59.5, you can get it from a 58.5. The online tests count the same as the problem solving homeworks. Both are 10% each. The conceptual homework is worth 5%. The three face to face tests are worth 30%. The final exam is worth 25%. And then your lab grade is worth 20%. Whoever you have for lab will tell you how that grade has come about, but they'll just report that grade to me and I'll throw it in the weighted average calculation where you basically multiply the 0.20 since it's 20% times the average grade that that instructor gives me. And then I add that to all the other grade columns multiplied by their percentages. And then I divide by the total percent, and that gives me the weighted average. You can see here the practice test bonus, 5%, meaning I'm going to take your grade out of 100, divide it by 20, and that many points will be added to your final exam. Let's see what else. All this stuff you should read over completely. Just do it in several spurts so you don't, get so bored that you forgot what you're doing. But the main thing I wanted you to see, in addition to understanding how the practice tests work and how the grades are weighted, is I wanted you to see at the very end here the cut and paste area. So if you go to the end, it says begin cut and paste area. I do not mean to include this when you cut and paste. No, I want you to include this when you cut and paste all the way to here. Okay? Not with that last bit. Sorry about that. So it should just go from the I down to the student number like that. So that's going to be cut and paste into a Word document, and then you're going to type the answers in these blanks. You're going to type your name in that blank, answer, 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 and then you're going to write your name here, and then you're going to write your student ID number there as well. You don't have to actually sign it because you're turning it in to me through Canvas, and you can't have access to Canvas unless you have your password and all that stuff. So it's automatically just as good as a signature. I want to show you where that'll be turned in, and I will in a second. But I wanted to warn you, I got some students this summer really just had a really hard time. I say some students. It was like three students that consistently complained to me. Uh, and I realize now that this is probably part of it. One student told me specifically, your Canvas course is a mess. Well, here's the problem. When I copy my course from one course to another each semester, it automatically fills in all these assignments. So all these assignments are on there and they've got these stupid due dates from previous semesters. So you're automatically inundated with all this crap and you don't have to be thinking about that. I have not figured out a way of getting rid of all this stuff unless I make it a nightmare for myself, meaning I would have to spend several hours getting rid of it and then several hours throughout the semester to bring it back up when I need it. So I want you to ignore this stuff. This is not the way you want to go about figuring out what you have to do in my class. What you want to do to figure out what to do in my class is you go to the modules, and this is a module in Canvas. Each of these little gray bars represent the top of a module, and you can click on it and see all the stuff in there. This is all the stuff the community, the college actually has me put in each person's class. So every instructor has these same sort of things. That means it's really generic. The other stuff is stuff that's important to me. Like here's the invitation to this meeting that we're having right now. Here's a bunch of important links to things that you might find helpful. These aren't the important ones. Sorry about that. This is the important one. These are ones that are just interesting science links and sciences of all sorts of areas. Notice I've got psychology down here and stuff like that. But the main thing is this one right here. There's a video that tells you the importance of the syllabus. I recommend you watch that. And then here's a PDF of the syllabus that you just saw in that area right there. These are ones that only I can see. They're like the originals. Here is a Zoom office hour slash invitation that from a previous semester. You don't need it. It's garbage. That's why it's not checked, so you can't see it. Here's the equation sheet that you're allowed on all the tests. and they're actually included on the online and face-to-face tests. They're at the very bottom, as well as all this stuff. So this is all the stuff that will have at your fingertips when you're taking the test. It'll all be at the bottom of the test in electronic format. Uh, Here's some stuff about taking an online proctored test. There's ways that, as I said, that can be done, but it's a lot of hoops and bells and whistles and things you got to deal with. So I recommend you using the me or the testing centers for TCC. If you can't, that's okay. We just have to go through the process to get it. Here's a link to my YouTube channel. Here's a list of my YouTube videos. That's not the best list. I think I have a better one. I have to put it here later. I have a better list that's more complete. Notice that one's really old. That's from 2022. I've got one from 2025 that I'll put up here later. And here's a link to our Google Docs. Okay, the Google Docs is where I store the notes that I fill out each day we take an online video or a Zoom session, or each time I make a Zoom session solving a problem, I take the notes that I did on the video and I put them on my YouTube channel. And if you go to my YouTube channel, you'll see in the box where it describes the video, there's a little code in there. It'll say like PHY 241 N02B 07 252025. Well, if you go to Google Docs and type in that 07252025, boom, out will pop the notes from today's lecture. So that's the advantage of that little code. Here's some more stuff that's totally just interesting, and it answers the questions that students often ask of me. That's why it's there, but it's not necessarily relevant to the course. If you are taking your practice test and discover that you're taking a test on chapters 1 through 6, and you find out that chapter 5 is really difficult and you're making a lot of mistakes, you might want to drill down just in chapter 5. So you can keep taking the practice test, but that gives you chapters 1 through 6 every time, and there's only a limited number of questions and there's a limited amount of time for you to take them. Here you can just go and just take practice on chapter 5. So that's what these things are for. They don't count as extra credit or anything like that. I can tell that you've taken them, but that's about the extent of it. Uh, so far, I've only confirmed that 1 and 2 are working because we're not going past 1 or 2 right now. But by next week, we'll have chapter 3. I'll make sure, but probably within the next week, I'll have all of them checked out to make sure they're all working. Here is where the practice test is. You can see the first practice test is up. It's due September 14th, and that's because specifically the online test 1 that this is for is due September 14th. Here's the online test. Notice it's due September 14th. I've already done that as well, so that's there. And this is where the face-to-face test will be. You can see it's not green, so you won't see it on your side, but that's where it'll be. This is week 1. So when I told you you should be using the modules to figure out what you're supposed to do, this is basically what you're supposed to do. If you go down, you say, oh, my homework links are chapter 1 and chapter 1 conceptual. So there's the 2 homework assignments you got to do. There's also, there's more to it than this. I'll say, for instance, assignment, and there's 2 online homework assignments that you're responsible for, even though they're not showing right here yet. I'll have to figure that out in a second. Here it is. So, Introduction to Mastering Physics and Physics Primer. Those are technically extra credit, but you're supposed to do them, and you'd be crazy not to because they teach you how to use the homework system that we're using. You can see that their date's already set to September 7th. That's when they're due. And chapters 1 are due on this date is not technically correct. If you click on it, it'll give you the accurate date, or I can go up. Notice it says May 29th, 2024. That's clearly not accurate, but I did already correct it. If I wanted to see, for instance, let me see if I can do it here. Yes. So once I sync these grades, which you can see I've done, then it'll show the proper dates. It just takes a little while for you to see it. So if I wanted to look at it here, what I do is go to Instructor Tools, Assignments, and you can see Chapter 1 is due 8/31. Chapter 1 homework is due 8/31. Physics Primer and Intro to Mastering due 9/7. And chapter 2 is due 9/14 for conceptual and homework. Those are really the only ones I've set up. But, anyways, that's what the due date is for those and how those are supposed to go about being done. So you can see all you have to do is go down here and click this, and it'll take you to the assignment. They told me specifically not to put dates on the Canvas side, and I don't. It just automatically updates them. It'll probably do it tonight at midnight, but right now we're just looking at the modules. So as I said, for week 1 module, you see that we have homeworks for chapter 1. So that means we're only doing chapter 1 in week 1. And that's the only homework assignments that are due for week 1. But those 2 extra credit ones, they're technically due next week, September 7th. That's Sunday of next week. So you can see that they're available too. These are all, I said, optional videos, but they're videos that can help you better understand how to solve problems and stuff like that. The ones that are marked lectures are full lectures, so you'd want to fast forward through parts of it just to get to the problem solving. And then there's other ones that are just teaching you stuff like this one, Introduction to the SI, Scientific Notation and Standards, Unit Conversions, Multiplicative, converting between Fahrenheit and Celsius, converting between Celsius and Fahrenheit, dimensional analysis. That's a lecture, so that's another long one. But the rest of these, if they don't say lecture, they're not really full lectures. They're just problem solving sessions that can be found on my YouTube channel. If you click on them, sometimes this will happen. All you have to do to remedy that is click this little button right up here. Okay. And you can see here's one of the little codes right here 01212023. This isn't the best example because this is a specific problem instead of a lecture. The lectures are a little bit more handy, but you can see in this case I'm converting 1 mile per minute to something, but that's mainly what that's about. So if I go back to the modules, you can see all of these are there to help you better understand the course material in case I don't get to all the examples that I want to. Here's a plethora of examples. You don't have to watch any of them. You might want to watch several of them. You might want to watch only one of them. There's a lot of stuff in here, scientific method, introduction to measurement and estimating, definition of a leader, and all sorts of neat little problems you can solve here. All of them are helpful, but you don't have to necessarily use them. Then, in terms of lab, if you were in my lab right here, you'd see Intro to Lab. This is where you turn in your lab, Intro to Excel, Introduction to Excel, all sorts of stuff. But you're not in my lab. In fact, someone else is teaching my lab for this class. But I put these things up here just so you can have them for whatever lab you're taking. These things might help you. Not necessarily the labs, but the introduction to lab doc, the how to read your vernier calipers, significant digit rules, sig figs when they fail. And I've already got 2 extra credit problems listed for you. Okay. If they have the EC on them, or if they're a chapter that we're not required to cover according to the syllabus, then they're automatically going to be extra credit. So the EC being in it means it's extra credit. Or if it's some chapter other than 1 through 11, 14, 15, and 36, those are all going to be extra credit as well. Any questions on all this stuff? I'm going to get rid of this lab. Unpublish.
Yeah, I was wondering what should we bring to lab because there wasn't a separate lab book when I went to buy books, so I was wondering what do we need to bring to lab?
Yeah, we've made that free for you. So the way I do it, and different instructors do it different ways. I'm not sure how Mr. Johnson's doing it, but I think or Dr. Johnson's doing it, but I think that's who you'll have. But either way, he has the electronic version of the lab manual, and he will either give that to you or print it out and give it to you. So you don't have to pay anything for lab manuals.
Okay.
What
Um,
you will need is a calculator, paper. If you have a desktop or a laptop computer that you use, that can sometimes be handy. But we do have computers for you in the lab as well.
all right. Okay. Thank you.
No problem. All right, so now that we've gotten all that done, I'm going to go ahead and jump into chapter one and covering material. So I'm going to stop sharing this screen and I'm going to start sharing my iPad screen, and let's hope that it works. So I'm going to do share, advanced, iPhone, iPad via AirPlay. So that should allow me to bring this up in just a second. Of course, every time I say something like that, it does just the opposite. Yeah, this is not helpful. It's being a pain. Er, that was not what I wanted. Why is this not showing what I want? Okay, still working on it, folks. All of a sudden, my iPad has stopped allowing me to share my screen. Why is that not showing there? That's not good there either.
Sir, while you're experiencing technical difficulties, may I ask you a
Yes.
quick question?
Yeah, go for it.
Do you have a specific calculator that you recommend for this course?
No, if your major is engineering or one of the physical sciences, I would say just get you a graphing calculator. But you don't really need that, but I do allow you to use it. So, for instance, I have a Casio FX C650, or maybe that's no, that's a CG50. Sorry about that. And that one's really nice, but it's way overkill. You don't really need that fancy one. If you just get the cheapest scientific calculator you can find, that will be fine.
Thank you.
No problem. All right. Anybody
And
have any idea what's going on with my iPad? Go ahead.
where did you want us to put the cut paste Word document for the
Oh,
syllabus
yeah, I didn't
again?
show you that. Thank you. I'm going to stop sharing again because I'm having problems with sharing to begin with. And I'm going to go back to the regular and I'll show you that real quick. I forgot to point it out to you. And it might not even be there. That might be why I forgot. Let's see. So I'm going to go over to here, week one. I don't see it now. Yeah, I don't know why it didn't end up here. I made it for all my classes. Okay, so here's where it's going to be. I'm going to do assignment, create assignment, syllabus copy and paste. Now, this is going to be right up here. Now you should be able to see it. And what I will show you is you just have to put a value in there. That's the main thing. Uh, Submission online and the file upload, restrict it to a type PDF. And this is due September the 8th.
PDF, not a doc for Word documents?
Yeah, I'm basically there's a lot of ability for us to get viruses through Word documents, so I try to do it in PDF. It's slightly less risky, but maybe basically that's why. So I only accept things in PDF form. But in case you don't know how to do that, all you have to do is do file save as, and then you change it from a docx to a PDF, and Microsoft Word will automatically change it for you. If you don't have Microsoft Word, you get free access to it while you're a student here. And you can call the 822 1122 number to get help on that. They'll help you download the entire Microsoft Office suite. Does that help you? You see where that is now?
Yes, thank you.
Okay. No problem. All right, so stop share again. Let's try to share again the proper way. I apologize for this. It worked just before class started, but now I can't get the Apple screen to come up where it tells me I can see if it's on here. Nope. Nope, not there. So normally I swipe down with my iPad and a whole screen comes up and it gives you like screen mirroring and stuff like that. But when I do that, it also has an option for me to display what's here, but it's not giving me that. Anybody have any ideas about what I could do to help it? Because I'm really like running out of ideas here. I'm trying everything. It's not there. It's not there. Cellular data off. AirDrop, no. Personal hotspot, no. It's like most of the icons are there except for the one that normally is there when I'm trying to save it. Choose Zoom Williams iMac Tech. Screen. Okay, so maybe it moved it to screen mirroring, but that wasn't where it was a second ago. Ah, there it is. I wasn't patient enough. I apologize, everybody. It was actually working, but it wasn't showing me that it was working. I apologize. All right, so now we have this. I want to remind you that if you need to email me, that's the username that I use, and then you know what the last parts of my email are. I don't want to put that up there, but I just wanted to mention it to you. You have obviously my YouTube channel listed up here at the top. What I first want to talk to you about is a little bit about the scientific method. You'll notice your book handles it quite a bit differently than you're probably used to. Most of you are probably used to what you learned in grade school, where there's like this list. You make an observation, you make a hypothesis, you do this, you do that. That was all made up from the very beginning by book publishers. Your book talks a little bit about really how some science has been worked out. For instance, it talks a little bit about Galileo versus Aristotle. Later, you'll learn about Einstein, the way he came up with things. What I'm going to tell you is when we ask questions regarding terms like theory, hypothesis, law, you're going to answer such questions on all the tests from the perspective of the textbook author. So I want you to read that thoroughly, get an understanding. That's probably the easiest section in the entire book to read is the first few sections on the scientific method. Uh, I will tell you that in general, we as a community of scientists are trying to reclaim the word theory from what it's been turned into, where a lot of people use what should be the word hypothesis, but they use the word theory and they'll say, well, that's just a theory. We're actively trying to get rid of that idea, but we're also actively guilty of it because we inevitably make the same careless mistakes in everyday language too. So, your book doesn't address that very much, but that's what I tend to address. And what I've discovered is the students, I think they might get some benefit out of it, but it makes it a little more confusing when they're trying to answer the questions on the actual test about uh, laws, theories, hypotheses. I will tell you that basically there's models that we use that may have no bearing whatsoever on the reality, but the main thing is you're using that model to motivate something that can be predictive. And once you make a prediction, if you can make it quantitatively, then you can do an observation or an experiment to see if your prediction is right. And only if your prediction is falsifiable is that a scientific prediction. If it's not a falsifiable prediction or hypothesis or theory in the bad way of using it, then it's not scientific. So you've got to be able to falsify it. It's not that you can prove it correct, it's that you can prove it wrong or false. Okay. So that's something that I want to make sure you guys know. But other than that, I'm just going to tell you to stick to what your book says about laws and hypotheses and models and stuff like that. I will tell you that we need to have some understanding of the measuring process. When we make a measurement, we can't measure to an infinite number of decimal places, so we can't really test to an infinite number of decimal places. So, by the nature of it, it's physically impossible for us to prove anything. And in fact, I want you to realize that that's the strength of science. We don't have laws in the sense that they cannot be violated. We have laws in the sense that this has been tested over and over and over and over and over again and never been found to be in error. But it only takes one experiment properly done that can be repeated, and that law would have to be thrown away. Okay. That is a strength that keeps us from creating what we would call dogma as opposed to actual science. Okay. So keep that in mind. But really, the meat and bones of all this is understanding about numbers. So, for instance, if you take a typical centimeter scale like I have here, you can see this is actually in inches across the top. You might not be able to see it at all because it's clear and it's really hard to see. But it's in inches in the top and it's in centimeters and millimeters in the bottom. Uh, it's actually all in millimeters. But when you're using this type of measurement, what I have marked on the left side, not at the end, but just shy of the end, is the zero mark. That's a good measuring device. You don't want the end of your measuring device to be the zero because the end of a measuring device gets mangled, it gets dropped, it gets dented, all sorts of stuff. So it's better to have one like this, where the measurement of zero is close to the end, but not exactly at the end. Then you want to count the distance or the number of spaces between any two consecutive digits, like the digit zero and the digit one. So if you look, in this case, it's 0 and 10, so we're doing millimeters. That's not very helpful. But with a centimeter scale, between the 0 and the 1, you'd see there's actually 10 spaces. And they're all the same size, so that means each of them is a tenth of a centimeter. So that has some important information. That means if we go to measure it and it's a particularly easy measurement, then we can definitely guess the first decimal place because it's in some sense whatever the last line it's past is. So, for instance, if it goes past the 1 followed by 2 spaces, that would be 1.2. So we'd say it's 1.2 centimeters. But if it's really easy to measure, we can probably get another digit out because we can say, well, it's clearly not 1.29 and it's clearly not 1.21. Maybe we don't know the difference between 1.21 and 1.22, but we certainly know the difference between 1.21 and 1.29. So somewhere in that last digit is really the uncertainty. So we might record a measurement, for instance, as 1.23. And of course, all measurements are almost essentially meaningless unless we know what system of units you're using. So I have to write the unit there. Now, when you see this written this way, that means it has an uncertainty of plus or minus 0.01 R, 0.02 R, 0.03 R, dot, dot, dot. The best case scenario is 1 in the last decimal place. So this is the best we could hope the error to be in this measurement of 1.23 centimeters. If, on the other hand, we measured a number and it said 1.5 centimeters, then the error is plus or minus zero point 0.1 or plus or minus 0.2 or dot dot dot. And of course, all these are actually in centimeters as well. I just chose not to write them. So inherently, what I want you to understand is if someone gives you a number like 1.5, you have to be willing to assume that the uncertainty is at least zero point 0.1. If they give you a number like 1.23, you have to assume the uncertainty is at least zero point 0.01. Okay? That being said, there's a quantity called the fractional error that comes in handy. Oops. First off, we say the error in 1.23 centimeters is greater than or equal to plus or minus 0.01 centimeters, and that is given the symbol sigma. So that's what we normally use for the error. The fractional error, on the other hand, is usually written sigma x over x. Meaning, if we called the measurement 1.23x, then we would say, oh, the error in x is 0.01 centimeters, and we would call that sigma sub x. And then we'd call the 1.23 centimeters just the plain x. So in this case, we would say the fractional error, sigma x over x, is 0.01 centimeters over 1.23 centimeters, and that is a unitless quantity. So I take 0.01 and divide it by 1.23, and that gives me 0.0081, and that's the uncertainty. But you could say the percent uncertainty is sigma x over x, but just written as a percent. So it would be, in this case, 0.8%. And we rarely use more than one sig fig when we're talking about error, fractional error, or percent uncertainty. Okay. So this actual question, 1.5 centimeters with a just given to you, or 1.23 centimeters given to you, in your actual practice tests, as well as the online tests, as well as the face-to-face tests, you will run into questions where it'll say, what's the fractional uncertainty of 1.23 centimeters? What they're expecting you to do when you're asked that is they're expecting you to assume a 1 in the last decimal place, so 0.01, and then you're going to take that 0.01 and divide it by 1.23, and then you're going to convert it to a percent or turn it as a decimal, depending on which question you're doing. So you'd either put 0.8% or you'd put 0.008 is the fractional uncertainty. So that's just a question that I know appears repeatedly, and questions like that appears repeatedly, and you need to understand that's going to come. Okay, so just remember, best case scenario, a 1 in the last digit you can measure. If the measurement's easy to make, you can always make one measurement beyond the smallest markings on a ruler. So that's when you're measuring distances. When you're measuring something digital, like on a meter or on a digital display, like your modern speedometer says 2.5 on it or something like that, then all you can assume for the uncertainty there is plus or minus 1 as a whole number. But the other thing is that's going to be the uncertainty of it, is plus or minus 1. If you look in the manual for your car, for instance, it might say, no, the error is actually plus or minus 2 or plus or minus 2.5 or something, in which case you want to correct it for that. But if they don't tell you anything else, you should assume that it's 1 in the last decimal place. Now, another thing that the book will bring up in actual quizzes and online tests is I will give you, and you'll see these in Module 1 when you're looking at the definition of sig figs and scientific notation and all that stuff. You'll see a very specific definition that I give you guys for scientific, or excuse me, for significant figures. And basically, my definition says the number 5,000 has 1 sig fig. So I'll say me implies 1 sig fig. The textbook author, which is his name's Giancoli, he would say the answer is ambiguous. That's another question that pops up in this, and I want you to understand why. If I have the number 5000 with a dot by it, then me would conclude that this has 4 sig figs. Okay? And Giancoli would agree. So the difference is the way we count sig figs. Giancoli tells you specifically, he says, hey, if a number's like 80, you're going to assume that it's good to 1 significant figure or to 2 significant figures unless it says something specific like it's about 80 kilometers. If it's about 80 kilometers, he wants you to assume that's 1 sig fig. If it says the distance between such and such and such and such is 80 kilometers, then you're assuming it's plus or minus 1 as an uncertainty. You can see how that's a little ambiguous, and that's what he's trying to do when he asks you these questions like, how many sig figs does the number 5,000 have? Okay. My way of counting sig figs is you first determine if there's a decimal present. If there is a decimal present in the number, then the leftmost non-zero digit is the most significant digit and the rightmost digit is the least significant. Both of those digits are significant, and any digits between are significant. If, on the other hand, there is no decimal present, then the leftmost non-zero decimal, or excuse me, non-zero number is the most significant digit, and the rightmost non-zero digit is the least significant. So, for instance, you can see the number 5,000 clearly only has 1 sig fig because it has no decimal present, and the leftmost non-zero digit is 5. So that's your MSD. And since you have no decimal present, the rightmost non-zero digit is your least significant digit. So we'd say LSD. Therefore, this one has only 1 sig fig. If you do that same thing with the 5,000 with the decimal place, you see the leftmost non-zero digit is the 5, and the rightmost digit, because there's a decimal present, is the LSD, and that's why you have 4 sig figs. So that's the way we count sig figs in a real lab setting or something like that. That being said, we're going to talk about propagation of error some point in the semester, and that's way more important than sig figs. Sig figs is not what real scientists use. Okay, they might use it for some piddly stuff around the department, but if they're publishing something, they're not using that. Okay, so we'll talk more about that later. That being said, we need significant digits to understand, for instance, precision, accuracy, percent error, that kind of stuff. So we're going to talk about that a little bit later as well. What I want to do is I need to introduce you to the System International, what we call the SI, which used to be called the metric system, and it's sort of okay to still call it the metric system. But the metric system was also introduced to some extent around the time of Napoleon when we were using the CGS system. So the SI is equal to the MKS system, which means meter, kilogram. Whoa, I really did badly there. Meter, kilogram, second. Okay, so it uses the base unit as for mass as the kilogram, which is much more reasonable in everyday life because gram is a very small amount of mass. There's also the CGS system, which means centimeter, gram, second. And in that case, you can see the centimeter is actually not too bad for a unit of length, but the gram is really unpopular, so we don't use that. That being said, the SI system has a mnemonic that I'll teach you, and I highly recommend you make up your own. But here's mine: the dot dot great dot dot monarch dot dot King Henry died, here's the base, by drinking chocolate milk dot dot under. Notice that's a mu. That's a Greek letter mu, not a u. But I'm using it like it's a u. If you type in Microsoft Word a lowercase m, highlight that and change it to symbol, you'll see what the mu looks like. So the great monarch King Henry died by drinking chocolate milk under dot dot numerous dot dot. And here's where my seventh grade brain always kicks in, and I use the P to represent the world's oldest profession. I highly recommend you using something better than that, but yes, my brain is chronically stuck in sixth/seventh grade, so all my jokes are about poo poo and stuff like that. So I'm a little bit childish. All right. Now, the other thing to remember here is the base unit is supposed to be anything that doesn't have a prefix. Now, again, in the SI that we're using in this book, any formula that has M in it is expected to be put in a kilograms, okay? Unless they explicitly tell you otherwise. So, in some sense, the kilogram's the base, but it's not really the base because it has a prefix. So, for instance, you could have the gram, you could have the meter, and you could have the second. And believe it or not, those three can get you a lot of stuff. We can figure out, for instance, the unit of mass. Obviously, that's the G. The unit of length, that's the meter. The unit of time, that's the second. But we can combine those to make velocity, meters per second, or acceleration, meters per second, or force, kilogram meters per second, our energy, kilogram meter squared per second, our linear momentum, kilogram meter per second, so on and so forth. Okay, so just with those three base units, you can make up a ton of stuff. Now, the way we deal with this is we do a more rational system of units where each individual separate unit is a factor of 10 or some power of 10 different than the other ones. That's in stark contradiction to this crazy thing you might have seen in grade school. I call it the G-Man, and it's basically how we try to remember the stupid units that we use when we're talking about gallons. A gallon has 4 quarts. Each quart is made of 2 pints. And of course, a pint is made up of 2 cups. So you put a C and a C, a C and a C, and a C and a C. And inside the cup is 8 ounces. So you put 8 O's. You can see that's a real pain in the butt. It's a historically established system of units, and it's not rational. That's why, around the time of Thomas Jefferson, we started switching this stuff to make it rational. So if we want to talk about a decagram, that's what the DA is. that means times 10 to the 1 power. If we want to talk about times 100, then that's 10 to the 2 power, and that would be a hectometer. Or if you want to talk about 10 to the 3, that's a kilo. And then notice the dots matter. So this dot would be 10 to the fourth. This dot would be 10 to the fifth. This one's times 10 to the sixth. This one's times 10 to the 9. And this one's times 10 to the 12th. So the prefixes there are tera for T, giga, or if you watch Back to the Future, giga, that would be acceptable as well. Capital M is mega, megamind. Uh, you also have the K for kilo, the H for hecto. That might be hecta, I can't remember, but I think it's hecto. And then the DA for deca, DEKA, but it's technically supposed to be a DA. And then the base is just like grams or meters or seconds. And then times 10 to the negative 1 is a decigram, and times 10 to the negative 2 is a centigram, and times 10 to the negative 3 is a milligram, a microgram, a nanogram, and a picogram. Okay? So that's the way the System International works. And from that, we can get what we call equivalent statements. So, for instance, you could say 1 terameter is equal to 10 to the 12th meters. That's how you can interpret the fact that I've got a 10 to the 12th written by the tera. Now, if you want to do pico, you can say 1 gram is equal to 10 to the 12th picograms. Or another way you could say it is 1 picogram is 10 to the negative 12th grams. When you have two separate numbers on opposite sides of the equals with, for instance, opposite or different units, then that's what we call an equivalent statement. And an equivalent statement can be used to make the number 1. So why is that relevant? Well, if you're asked to convert a certain number of teragrams or a certain number of kilometers to a number of meters, okay, uh, you can add, subtract, multiply, and divide. But it turns out that the vast majority of unit conversions take place through multiplication. And the only thing you can multiply a number by without changing its value is the number 1. So, with that in mind, we use equivalent statements to form the number 1. So, 1 could equal 6 over 6, or pi over pi, or it could equal 1 foot over 12 inches, or it could equal 1 gram over 10 to the 12th picograms. But you could also do it another way. Each of these could be turned upside down. So the main thing that I want to get through to you here is how to use these equivalent statements to convert units. For instance, let's take the velocity 60 miles per hour. Now, per means divide, so I want you to think about that. And I want you to always, when you go to convert units, is to make the original number whose unit you're converting into a fraction so you don't make careless mistakes. The fraction in this case is going to be 60 miles divided by 1 hour. Because remember, any number can be divided by 1, and then you have a fraction. right? If it's already in fractional form, just put the denominator with the denominator's units, and that works just fine. But that's the way I would write it out. And what I would like to do is convert that to meters per second. Now, I can convert it to a lot of things on the way. So I'm going to show you that. I'm going to say 60 miles over 1 hour. So first off, I might want to convert it to feet per hour. Well, if that's the case, I can say that 1 mile is equal to 5,280 feet. And notice that the mile in the denominator can cancel out with the mile in the numerator. That's part of how we know that the 60 is being multiplied by the units in the numerator. The 1, which wasn't there at all, can be written there because you can always assume a 1's there. And then the 1 is being multiplied by hours. So if we actually carry this part out, this would give us the measurement in feet per hour. But we don't want that. So I'm going to continue on and I'm going to say, okay, well, let's maybe find out what it would be in feet per second. Well, I could say 1 hour is equivalent to 60 minutes. So I could write 1 hour in the top and 60 minutes in the bottom, or I could write 60 minutes in the top and 1 hour in the bottom. Since I want to get rid of the hour, I need to put that on the top. So I'm going to say 1 hour and 60 minutes, like that. Now I can see that this hour cancels out with this hour up here, and that would give me feet per minute at that point. Notice how I'm using a different slash to mark out the units for each time. That's a good number keeping sort of technique to make sure you don't make any mistakes or that you can easily find your mistakes when you do make them. Now, this has brought me to feet per minute, but I want feet per second, so I'm going to go ahead and use another statement, which is that 1 minute is equal to 60 seconds, or 60 seconds is equal to 1 minute. I can put either one on the top and the other one on the bottom. In this case, I want to get rid of the minutes, so I'm going to put 1 minute on the top, and I'm going to put 60 seconds in the bottom. Now, I used a slash that went from bottom left to top right, and I used a slash that went from top left to bottom right. Now I'm going to use a complete X. So now I've gotten yet a third way of slashing things out. And in fact, this whole calculation right here has given me the number of feet per second. So I could stop there and have feet per second, but I'm going to keep on going and I'll show you how to do this calculation anyways. So now that we've got it in feet per second, I want to continue to get meters per second. And I'm going to use a series of numbers that are exactly defined so that if I use 2 sig figs going in, then I get 2 sig figs going out. But not only that, if I use 42 sig figs going in, out comes 42 sig figs. So that's the advantage here. What I do know is that 1 foot is exactly equal to 12 inches. So should I put the feet on the bottom or on the top for this one?
Bottom.
Exactly. So 1 foot is in the bottom and 12 inches is in the top. Now, this might not necessarily seem reasonable to you, but you'll see why in a second. So the slash mark I'm going to use for feet is a curly one that goes from top left to bottom right. Now, I happen to know that 1 inch is exactly equal to 2.54 centimeters. So should I put the inch in the numerator or in the bottom?
Bottom.
Exactly. So 1 inch is equal to 2.54 centimeters. Now I'm going to go bottom left to top right with a curve. Okay, so I've marked that out. Notice I'm now up to centimeters per second. I just need to get to meters per second, and I happen to know just like there's 100 cent in a dollar, there's 100 centimeters in a meter. So, do I want the centimeters in the bottom or the top?
Bottom.
Exactly. So I'm going to say 100 centimeters is in the bottom and 1 meter is on the top. And now my X looks like this. Again, that's not really necessary that you do all of this, but I have discovered that it makes it a lot easier to track your errors, and I found it helpful for that reason. Now, we don't have much room to put that number there, but I want you to understand how you go about doing this when you do a long trail of calculations. What I recommend to my students is just multiply all the numerators. So 60 times 5280 times 1 times 12 times 2.54, and that gives me 9,656,064, and the only unit left in the top is the meter. And now I do all the denominators and multiply them. So 1 times 60 times 60 times 1 times 1 times 100. Sorry about that. I made some careless mistakes here. So 61 times 1 times 60 times 60 times 100 gives me 360,000. And that's seconds. Now all I have to do is divide the numerator by the denominator. So I take 9,656,064 divided by 360000, and that gives me 26.8224 meters per second. So 60 miles per hour is 26, basically 27 meters per second. The way sig figs work is the number of sig figs you have in the factor with the least is the number of sig figs you have to round the answer to. I started with two, what I assumed was two sig figs in the number 60. Therefore, I can't put any more than two sig figs after it. But the way I did this conversion is super helpful, because doing this conversion with these numbers means it's an exact conversion. So if I, for instance, put in six numbers, then all six of these sig figs would be correct. So 60.0000 would be exactly 26.8224 meters per second. Any questions on that? All right, so you
Wait,
now,
hold on. You said there was two sig figs there, but there's no decimal after the 60. So wouldn't that only mean there's one significant figure? So it should be 30 meters per second?
exactly. That would be correct. The good news is, other than that one question I warned you about, I'm not going to split those hairs for you. I'm never going to make you tell me whether 60 or 60 decimal is one sig figs or two sig figs. I was using the book's practice in doing that. Okay. So I don't grade that strictly on the tests and stuff like that regarding sig figs, but I try to be very, uh, obsessive compulsive about proper sig figs when we're doing problems, just because I know the homework system, even though I turned off the sig fig stuff, the homework system very much hinges on sig figs. So I want to show you how to do it properly, even though I don't care specifically too much about it.
Okay.
Okay, but no, you're exactly right. My definition says that should be one sig fig. I was using the book's idea of calling it two sig figs. So, any other questions, anyone? Well, class is supposed to run till 6:50. We're pretty close to that. The one thing I haven't shown you is, regarding units, and we'll do more next time to finish up this chapter. But for instance, if you have the density of water is 1 kilogram per liter, that's not necessarily that complicated. But if you have the density of water is equal to 1,000 kilograms per cubic meter, that is kind of a big deal. If we want to convert this to grams per cubic centimeter, here's how I go about doing it. So 1000, which I'm going to assume is 3 sig figs, so I'll put that little dot next to it. And I'm going to say 1 meter cubed. First off, we can get rid of the kilogram because 1 kilogram is equal to 1,000 grams. I'll put a dot there too. Okay. So that gets rid of the kilograms. And now I've got grams per cubic meter, which is a million. There's a million grams in a cubic meter. But how do we deal with that cubic meter? Well, we know that 1 meter is equal to 100 centimeters, but that's a meter times a meter times a meter. So to do that, we have to write it again and again. Now you can see that basically this, or excuse me, cancels out each of these guys. Obviously, it doesn't cancel out the centimeter down here. That was a boo-boo on my behalf. But anyways, that's how you go about converting it. And lo and behold, what you'll get is equal to 1.000 gram per cubic centimeter. Okay. So that's how you do powers on a unit. Class is now over, and by the way, if you ever run out of time, you're free to go right at 6:50 or even a little bit before if you need to. I'm never going to count that. What I would like you to do is each of you chat me your first and last name in the chat window. That's what I use later for roll. So we're going to ask you to do that every day. I meant to ask you earlier. If you do that before you split, I'd be very appreciative. But you're all free to go, and I'll wait here until the last person leaves in case any of you have any questions. Thanks for coming, everyone. I do appreciate it.
Hey, Professor, I got one question.
Yes.
I emailed you about this, but I didn't send the right credentials, as you talked about
Oh,
this.
gotcha.
But I was wondering if there's any availability in your day class for the physics lecture at all.
Absolutely. Just show up, man. I don't mind at
Yeah.
all. Yeah, it's not
Okay.
a problem. The lab is the only time where we have a little bit of difficulty if you overfill that, but lecture you can attend anytime you want, and you'd always have this as a backup.
Okay, but would there be an issue with submitting the assignments at all?
Uh, no, you just still use the same Canvas page. In other words, you would still be officially in the nighttime class, but you just attend the other one, and everything will be fine.
Okay. And then what about the lab? Would there be any way? Because right now I'm in the late PM lab, and I know you
Mhm.
have one that's I think Wednesday or
Yeah,
something.
it was for 241. It's Wednesday morning at 9:30, and as far as I can tell, that class is pretty close to full. But I might be able to fit you in, and we can do it officially if you want to. I don't mind
Yeah.
overfilling my class. Let me check and see if my powers that be will allow it. If the powers that be allow me to overfill it, then I'll just overfill it, and you'll just be completely on the books in the other class. It'll take a couple days for you to switch from this Canvas course to the other one, but we're welcome to do that as well.
Sweet. Okay. Well, I'll just send you an email then, just
Okay.
so you remember. But yeah, thank you very much. I appreciate it.
No problem. I see your name Shane, so I think I did see an email from a Shane anyway, so that's probably
Mhm.
you. But yeah, I'm certainly willing to let you do that. No problem.
Awesome.
On
Well,
the books are off.
I'll be in the in-person lecture on Wednesday then.
Okay. Thank you.
So thank you.
Anybody else have any questions? I see y'all are typing your names into the chat. I appreciate that. I didn't even get a chance to ask people about being viewed on the internet. I should ask them later about that. Matthew, John, Thomas, Joshua, any of you guys have any questions? Ronnie, Johnny, Mickey, and Mike. All right, looks like
I'm
they're
good,
not
thank
here.
you.
Oh, okay, no problem. See you, Joshua.
No, just copying the notes.
Oh, okay, no problem. These will be posted tonight as well on my Google Docs too. So if you ever need that, you can always find it that way. There'll be much better notes in the future. Tonight was just sort of quickly fit in what I can. Thomas or Joshua, you still here, guys? Oh, I
How
see
many
Josh.
sig figs is the last question?
Uh,
Last answer.
I gave him three. So yeah, I was trying to make sure it was three sig figs. So yeah, that does turn out to be four total.
Why is that?
Just because I used 1,000 with a decimal. Notice if you look right here, there's a little dot.
Yes.
So I was trying to be pedantic and use exactly the right definition of 1,000. So I put 1,000 with a dot. That means one, two, three, four sig figs, and then all these had dots. So those numbers are not limiting me. Well, technically, I guess since it's 100, technically speaking, 1 meter is exactly 100 meters. So that's really good to 100 decimal places or an infinite number of decimal places. So all of these are infinite number of decimal places multiplied by four. So it should come out to be four decimal places or four
Okay.
sig figs. That makes sense?
Yes. Thank you.
Don't worry too much. Like I said, I try not to do much with the sig figs. I'm going to teach you propagation of error, which is a much more robust way, and you won't even worry about this stuff anymore.
Okay. Thank you.
You're welcome.
All right. Bye.
Have a good one, Joshua.
You too.
It looks like Thomas is probably gone. And oh no, he just signed that out, so he might actually just be there. You have any questions, Thomas, before I let you go, bud? All right, I'm gonna call it a day then. Stop sharing. Thanks again, everybody. Bye bye.